We're in a 2-week block where we're going to take a look at the cluster add and subtract within 20. And that cluster has one standard under it, 2.0A.2, which you see here. In the first part of this standard, students are to build their mental strategies for both addition and subtraction. And mental strategies take time to develop, but they should be based on sound numeric reasoning, and the work that we do towards that end is going to be really helpful in terms of developing children's number sense as well. The Common Core authors also clarify that by the end of grade 2, they should know all of their addition facts, all sums of two one-digit numbers. And so we're going to explore next what the authors mean by some of the language that's embedded in here. What do they mean by fluency? What kind of mental strategies are they referring to? And what do they mean even by know from memory, because there's more than one way to learn from memory. My daughter never saw a flashcard or a time test, my older one, and because the school she was in didn't use that approach, but she learned everything from memory using alternative methods. So what can we find out about the author's intent for how children get to that stage? I've used the expression fast and accurate to describe what fluency means in the Common Core, and that definition is pretty familiar, but it's necessary to explore further. Sometimes people assume that fast and accurate means that children need to know it by rote, that they need to know it without any thought. And sometimes, even though we want people to reach that as an end product, they think that's how you start. If you want them to end up learning something so well they don't think about it, you start out by teaching them in a way that doesn't involve thinking. I think you will find, though, that when you explore the Common Core documents, that really is not the intent of the authors at all. In this quote from the Common Core progressions, which the Common Core writers have also written, they specify that fluency includes just knowing some answers. Again, kindergarteners started working on the sums that all the facts that sum up to 5. Those should be things that are so familiar to them that they've just known them because they've worked with them so long, whether they had a flashcard or not. Then in first grade, a number of those facts have been used. So some of these facts have been used for up to 2 years by the time they get to you, and it makes sense that many of them are just known. However, it's also clear from this quote that fluency does not mean just know without thinking, because it includes and encompasses answers that they know from patterns and also from the use of mental strategies. Here we see 2 more quotes. The top one's directly from the Common Core authors, and the second one is from one of the Teaching with Curriculum Focal Points documents, and the curriculum focal points occur in the references of the Common Core standards. It was one of the documents that they looked at. There are 2 primary ideas here that we are going to extend as we tackle the subject of fact fluency. One is that it is a multi-year process. One of the grand advantages, or perhaps the greatest advantage of the Common Core, is its focus on building a coherent developmental approach to building mathematical knowledge and skills across grade levels. We'll be looking at how fact fluency is to develop across kindergarten, first, and second grades. Both quotes also describe a process of learning facts that use underlying patterns, strategies, and mathematical reasoning, not rote memory. To accomplish this goal will require a shift in practice for a fairly large number of teachers. And to see why the Common Core authors have suggested such an approach, where's that coming from? We're going to take a quick look at a research study that is listed in the Common Core references. The 1999 math standards for the state of California require that all basic addition and subtraction facts be mastered by the end of first grade, rather than the Common Core author's suggestion of the end of second grade. In the 2003-04 school year, Henry and Brown, 2 researchers, decided to investigate the teaching of basic facts in this really high-stake environment where all first-grade teachers were expected to emphasize basic facts acquisition. They wondered, in this high-stakes environment where everyone's so focused on accomplishing this goal, to what extent will the children be able to achieve that demand? In that focus era, if you still have a large number of students who don't meet that goal, it could raise some questions about whether it's developmentally appropriate. They also recognize that 2 entirely different perspectives exist on basic facts acquisition, with one focused on rote memory and practice, and the other focused on strategy development. So they were curious about which of these two approaches would be most beneficial, or whether there would be perhaps no statistically significant differences. Their research utilized 4 different schools, which varied widely in socioeconomic status, ELL population, and ethnic diversity. Here's a quote from the findings of that study, which included 275 students and 28 different teachers. Quote, "More than 80% of the way through the first grade, only 6.9% of the students demonstrated adequate progress on California's basic facts standard by retrieving at least 80% of the facts. Even for students attending schools ranked academically by the state in the top 10%, achievement was far from proficient. Only 10.4% retrieved at least 80% of the facts," end quote. The addition facts acquisition was 40%, so it was a little higher as you'd expect. The subtraction acquisition was 12.5%, but neither set of facts was even close to the mandated expectation. Henry and Brown concluded that the data raised some significant questions about the extent to which that expectation of mastery for all first grade learners for addition and subtraction was appropriate for first grade. And so you'll notice that the Common Core authors examined that and moved that expectation to the end of second. Referring to flashcards, practice sheets, and timed tests, the authors say this, quote, "In fact, none of these ubiquitous practice activities was found to provide a substantial contribution to the memorization of fluency with facts. Perhaps the most startling finding for the teachers is that frequent use of timed tests seem to actually work against student memorization and basic facts competence," end quote. The authors do go on to conclude, however, that they think that first graders could achieve addition basic facts proficiency if fluency would be defined as a combination of derived fact strategies and retrieval from long-term memory, and if teachers are provided with curricula and training that allow them to foster a developmental sequence to move the students on from counting strategies to derived fact strategies. They do not believe that the current curriculum, which is 3 major textbook companies, which was and they were all approved by the state of California, they don't believe that that current curriculum fosters this developmental sequence because the classrooms who adhered the strongest to the textbook actually produced the poorest results on the basic facts. If you look at Standards 2.0A.2, you will notice that there's a footnote reference in the mental strategies listed in the first grade standard. These are the strategies and patterns that were to have been introduced in first grade and which should continue to be developed in second grade. Although we will be primarily discussing mental math for larger numbers next week, the Common Core definition of fluency includes the use of strategies for single-digit sums. Therefore, we will be exploring these strategies shortly. First, however, let's take a look at the multi-year developmental process for fact fluency. Here you see facts up through 10 plus 10. The chart does not show the plus 0 facts, which children should experience and use a known pattern to solve. This pattern relates to the identity property of addition. It's not necessary that they know that name, but they should know that adding 0 to a number does not change the value of that number. The color coding on this chart illustrates the various mental strategies that could be employed to reduce the amount of memorizing. Essentially, all of these facts can be reduced to 4 strategies and 1 pattern. The green facts can quickly be solved by either counting on 1 or 2, and counting on by these small values is actually very efficient. The blue facts are doubles or near doubles. If they combine the doubles facts, which they should know well, with a +1 -1 strategy, then these facts can be quickly solved. The red and orange facts all take advantage of sums of 10, and you'll notice from this diagram that the red and orange sections together cover a significant portion of what we would consider hard facts. The red facts are sums of 10 and near sums of 10 where you can just use the +1 or -1 strategy. The orange facts require a little decomposing in order to make your 10. We're going to be looking at that make 10 strategy in just a moment. And then finally in yellow, you see a tens and leftovers pattern, and that pattern was first explored in the kindergarten Common Core, so it should be very familiar to your second graders. Here we have the same chart, and in gray it shows the facts targeted for fluency by the end of kindergarten. While kindergarten children will likely be working with all of the facts on this chart, the only facts that they have to bring to fluency, fast and accurate, are the sums up to 5. In first grade, then, they should come in with the facts that sum to 5, but fluency is also going to be extended now to the sums, all the sums up to 10. Again, students will certainly be working with these other facts and building mental strategies, learning to derive facts, but those other facts may still be slower in first grade. The remaining colored facts on this chart, then, are the ones that we need to bring to fluency in second grade. In the next section of this lesson, we'll be revisiting those first grade strategies cited in the footnote to this standard, and we're going to think about how we can employ them to bring second grade learners to mastery on the remaining addition facts. In the Henry and Brown study we just discussed, the authors found that children tended to rely too much on counting strategies rather than shifting to derived fact strategies. Counting on is a highly inefficient approach when the number added on is larger than 2. If the child feels under time pressure, it's also a rather error-prone method. Nevertheless, it remains a highly useful approach when the number to be added on is just like 1 or 2. In strategy development discussions with students, it would be helpful for them to develop a rule of thumb that if they have to count on more than 3 for sure, they definitely need a better method than counting on. One of the conclusions also in the Henry and Brown study is that teachers who fostered derived facts tended to focus almost too much on doubles as anchor facts. And that may very well be because children often learn their doubles facts first, so that may be one of the first anchor facts at their disposal. But the authors concluded that the students would be better served by having a classroom that especially emphasized sums of 10, because the orange and red facts on that chart that I showed you represent such a large number of the difficult facts. So the students will find many more facts at their disposal if they learn how to use that Make 10 strategy. So we're going to take a look at a Make 10 strategy for 9 plus 4. And as we go through this, I would like you to focus more on the mathematical idea rather than on my notation. As we look at 9 plus 4, we're going to try to make 10. And since 9 is so close to 10, it makes sense to use that to our advantage. Some children may do this strategy by saying, well, 10 plus 4 makes 14, and so 9 plus 4 is 1 less, so it must be 13. That's great. That's one way of doing it. We're going to take a look at a similar approach, and I'm going to model how I might draw it on the board as a student shares their thinking with me. The way that I'm showing you comes out of the Singapore math tradition. But if you find that representation unfamiliar, you can still use the same exact idea, but find a representation that works well for your students. A student might say, oh, I took 1 away from the 4 and gave it to the 9. Now, as a teacher, I'm going to try to model appropriate mathematical language. So I might say, let's go back to the 4. You say you decomposed it into a 1 and what was your other addend? Okay, you decompose the 4 into a 1 and a 3. So I just modeled the word decompose and addend. As you look at my notation, notice that I placed the 1 closest to the 9. This is to support my learners who may not yet have this strategy, try to follow what's going on. 10 is a very useful landmark in the number system. And so I want students to just be looking for opportunities to actually find that 10. Now, drawing the blue oval around the 9 and the 1, I would say, all right, then you told me that you gave the 1 to the 9, so I'm going to show that. Now, let's take a look at what we have. How does this help you, what you just did here? The child would then likely tell me that 9 and 1 make 10, and then there's 3 left over. So I would validate that strategy by saying, I love how you made good use of make 10. Class, Ramel says that 9 plus 4 is the same as 10 plus 3. Do you agree or disagree with that? Give me a thumbs up or a thumbs down so I can see what you think. And then we would, in a choral voice, respond to the question, what is the sum of 9 plus 4? So I'm trying to pull in the rest of my class to maintain their thinking about what's going on as we share strategies. So as I just got done saying a moment ago, 10 is a good landmark number, and it comes in handy for both addition and subtraction facts. Since the standard calls for fluency of addition facts and puts subtraction in the mental math category, we're going to look at an addition example here, but we could also use it for subtraction. Here's an example of a dialogue that might occur as a student shares the strategy that you see here with me during a strategy share. Student: I know that 8 plus 2 is 10, and then 4 more is 14, so the answer is 14. So I might say, you say you first did 8 plus 2, but the problem is 8 plus 6. Where's the 2 you're talking about? So the student might say, oh, I broke the 6 into a 2 and a 4, and first I added the 2, and then I added the 4. So then I could say, oh, so then I draw the number bond that you see here. Class, look at this problem and think about why Mia broke the 6 into a 2 and a 4. Why not break it into a 1 and a 5? Turn quickly to your neighbor and tell them why you think she did it this way. Now, my reason for pulling in the class to speculate on the inside of their peer is that my goal is bigger than just documenting Mia's strategy. I really want to facilitate the strategic development of the entire class, and I need them to be processing the kinds of decision making that are involved in developing the strategy that Mia is showing us here. The last strategy mentioned is creating equivalent but easier or known sums. This category encompasses a variety of strategies based on other facts that children have in their schema, whatever they already know. I've shown 2 examples here. The top one involves decomposing the 8 in 8 plus 6 into a 7 and a 1, and then giving that 1 to the 6. So I'm going to turn the whole thing into 7 plus 7, which should be an easy fact. The bottom strategy involves the child seeing a double embedded in a hard fact. So in 8 plus 9, a double is hiding. Can you find it and use it to solve the problem? Earlier in this lesson, we looked at how fluency expectations change over time, but the idea of a multi-year process doesn't just mean that we took the expectations and chunked them up across 3 years. There's actually a whole developmental process to how we acquire fact knowledge. Assuming that that fact knowledge is going to be both useful and long-term, it's going to require that kind of time. Let's examine each of these stages: preparing the learner, fostering anchor facts, fostering derived facts, and practicing for automaticity. Let's take a look at each of them. In addition to direct modeling or acting out and visual representations that help children make sense out of operations, children also need to become skilled at decomposing and recomposing number. So making sense of the operation and learning how to pull numbers apart and put them back together is really critical in the preparing the learner phase. Those continue to be important as students progress through the stages, but that's really the primary focus initially. So it shouldn't surprise you that some of this starts to show up in the kindergarten curriculum, like K.OA.3, and also is going to be practiced embedded in strategies in 1.OA.6. Second graders really should be beyond the preparing the learner stage, but I offer this to you both as background knowledge for where they've come, as well as a place to return if you have students with some significant struggles. The anchor facts that are most useful to addition are shown here. The counting on strategy shows up first, but notice that I've indicated +1 behind it. The strategy is also useful for +2, but it's just not very efficient for higher numbers. This will likely be the strategy that many incoming second graders are still using, according to the Henry and Brown data. Although you may not even perceive that they're using this strategy, particularly if they've been in a class where it was discouraged, children can become quite skilled at hiding the fact that they're really counting. They may hide their fingers, they may have other sophisticated systems for head nods, or a whole variety of them. Doubles and especially sums of 10 will be helpful for deriving most of the facts that involve larger addends. So we really want to foster those anchor facts, and then the next stage is going to get them past that counting. For large addends, we want them to foster using derived facts using those anchor facts that they already know. So once they have the anchor fact at their disposal, we're ready to go. Now we need to help them see how to use that and leverage that knowledge to tackle harder problems. In theory, your students should already have accomplished the previous 2 stages by the time they enter 2nd grade. Start of the year assessments then can help you hone in on just those remaining pesky facts that are still to be mastered, as well as helping you find out what their anchor fact knowledge is so that you know what your resources are that you can leverage for tackling those harder facts. Then your approach will primarily be fostering derived fact strategies for those remaining facts while simultaneously offering them reinforcement practice, which is here, reinforcement practice for the facts that they previously derived to get them faster. Deriving facts is not fast initially. Initially, it takes a lot of mental thought to construct a strategy and use it. However, with some practice, children, once they have those strategies, can get really fast at employing them. There are a variety of techniques for building that automaticity where they're just going to be fast and accurate, and they're listed here. We're going to talk more about those, however, in some subsequent lessons, so I will not elaborate any further on those at this point.